Use Descartes' Rule of Signs to determine the possible number of positive and negative real zeros of p of x equals x to the fifth minus 7x fourth plus 9x cubed plus 23x squared minus 50x plus 24. Then find all the real zeros and factor p of x completely using real numbers. Starting with Descartes' Rule of Signs, we look at the number of variations in sign in p of x. So we start off with a positive coefficient and immediately change to a negative and then back to a positive. So we've got two changes there. As we go through positive to positive, no change, but then positive to a negative is a change, and from negative to positive is a change. So we've got 4 changes here. So 4 is an even number, so we do all the even numbers from 0 up to 4. That's 0, or 2, or 4. And this is how many positive real zeros we can have. Then we look at the variations in sign in p of negative x. So every x that has an odd exponent, we're going to change the sign in front of, and the even ones don't change. So the odd exponent here, x to the fifth, becomes negative x to the fifth. Then here we have an even, so that doesn't change, minus 7x to the fourth. We have an odd, so that changes, minus 9x cubed. And here we have an even, so that does not change, plus 23x squared. Here we have an odd exponent. That changes, so we've got plus 50x and then plus 24. And now kind of counting the variations in sign, they're all negative here up until right there. So we change there and then they're all positive. So there is one sign change. 1 is an odd number. So we do all odd numbers between 0 and 1, which is just 1. That means that there is one negative real zero. Now that we know our possibilities, we can start to try out some numbers, and we're going to use the Rational Zeros Theorem to pick some numbers to try. Rational Zeros Theorem. So we take the factors of the constant term. So the factors of 24 are 1, 2, 3, 4, 6, 8, 12, and 24. That's a lot of numbers there. And we divide those by the factors of the leading coefficient. Now, the leading coefficient here is 1, and so dividing by 1 or negative 1 is not going to change the number themselves, okay? But we do have, of course, plus or minus in front of all of these. So these are the possible rational zeros of our polynomial. And now we just need to start trying them out. And it's not very fun, but we can do it. We're going to use synthetic division. We list out the coefficients of our polynomial. So we've got 1, negative 7, 9, 23, negative 50, and 24. And I'm going to go ahead and start with 1. Bring the 1 down. And you guys are comfortable with synthetic division, so I'm going to go ahead and just speed this up. Okay, and we've got a 0 here at the end, which is awesome. That means that 1 did work. Okay, and so we can keep going. 1 is a positive number, so we know that we're going to have more positives. Let's go ahead and just try 1 again and see if it works. And we are pretty dang lucky that 1 just worked again. So we've got so far 2 positive real zeros. So I know that that's a possibility. I could have more than that. I could have 4. Okay, so we're not going to quit trying with our positives. Let's go ahead and try 1 again. See if we could possibly have something that works 3 times. All right, we didn't get 0, so we're done with 1 working. So let's go ahead and just get rid of that work. And we're done with 1. Now we could keep going and keep trying to find the positives, see if there are more positives. But I'm going to go ahead and keep small numbers. So I'm going to now shift to -1 and start testing to see if that works. Okay, -1 did not work. So now let's move up to our next numbers. So 2 and -2 we can try out. I'm going to go ahead and just, because I know that there is one negative, I'm going to keep with negatives for now because I may not have any more positives. So I'm going to go for that negative right now. So -2. So we got 0, which is awesome. -2 worked. That's our only negative real zero. And now I am left with this these three numbers, which tells me that I've actually got a quadratic left after factoring things out. So let's go ahead and just write out what we have so far. We have x minus 1 as a factor, and it works twice. So we've got x minus 1 squared, and then we've got x plus 2, and then this right here, these are the coefficients of our remaining factor, which is x squared minus 7x plus 12. And that's actually pretty easy to factor. That is x minus 3 and x minus 4. And notice that the zeros that gives us are the two more positive zeros. Okay, so now listing all of our zeros, we've got x equals 1, which has a multiplicity of 2. And then from here, we've got x equals -2. That has a multiplicity of 1. And then we've got x equals 3 with a multiplicity of 1. And x equals 4 with a multiplicity of 1. And you'll notice then that if we count that up, we've got 1, 2, 3, 4 positive zeros, real zeros, and 1 negative real zeros, which falls in line exactly how we were expecting with Descartes' rule of signs.